more, you know, graphing,
We're getting
min-max.
introduced to E of X.
Yes, yes. So to make a rough sketch, you first, I guess, need to know the parent function for this one. And the parent function is y equals 10 to the x.
Mhm.
So any function y equals a to the x always has this growth shape, depending on the value of a. So if a is greater than 1, it has this growth shape to it. You can make a table. Do you know what you're doing in class for this?
No, we haven't. He actually hasn't like gone over problems like this.
Okay. So what the place you want to center your table at is whatever makes this 0. So that's at -2. Then you're going to go 2 smaller and 2 larger. Like the set, you're maybe used to the set of like, oh, let me try -2, -1, 0, 1, 2. That's shifted based on this up here. Maybe you saw that from a previous class or
Yeah.
before. So it's just a matter of being able to evaluate this. So you go right to the center, and this is 10 to the 0 power, because -2 plus 2 is 0, and that's 1. And then it's better to go this way. This becomes 10 to the 1 power, which is 10. This is 10 to the 2 power, which is 100. And what you have to focus in on is what's changing each time. Like it's going down by a factor of 10. Because you don't really want to write out like what this is. You don't want to show like 10 to the -3 plus 2. You just want to be like, oh, it's 1/10, or it's 1 over 100. See how these go down by 10, or you can think of it as going up by 10, but we got to go back and fill them in. So the rough sketch here, basically your instructor is looking for a few key points, like this one here, -2, 1. And see how -110 is way up here. So it's kind of hard to even graph this, but they're looking for this basically, like, do you know that it looks like that right there, a growth function? And you can't use a calculator, so you got to know what this stuff looks like. Okay, can we move on to 9, or would you like to make some comments on us? Okay.
That one's pretty simple.
Yeah. All right, so 9, and see, like we could spend a whole lesson on like just exponential growths.
I don't need to.
Right, but there's so much here, and that's why I'm just just be careful not to overwhelm you. But again, like you could make a table, but the other thing is the parent function here. The parent function is 2 to the x, which again is a growth function. It looks like that, but you got some transformations here. So this -x flips it. It becomes a decay function. So instead of it growing, it's kind of a terrible graph. It ends up looking like this. And then this negative out in front, the negative in front, okay, that flips it. So it looks like this now. And you'll see that when we make the table. But what your instructor is hoping you can do is like see all the transformations all at one time and go from the original to the new one. Is that okay?
Yep.
Okay, so we centered on whatever makes this 0, which is 0, -1, -2, 1, 2. So this is -2 to the -0 power. Order of operations is you do the exponent first. 2 to the 0 is 1. So this becomes -1. Okay. Now, normally you go this way, but because these are negative, it becomes -1. So these cancel out. It becomes -2 to the power of 1, but it's really 2 to the power of 1 first, then negated. So that's -2. So then it's -2 to the power of 2. This becomes -4 because you do that first. And then, so notice you go from -4 to -2, -2 to -1. You're dividing by 2 each time. Does So this is gonna be -1/2, and this is gonna be -1/4. Because you're going down by 2.
Okay.
And again, like we're just confirming what's already over here in the graph. So if I were to make a nice axis here and graph the nice points, -2, -4, -1, -2, 0, -1, 1, 1/2, 2, 1/4. You see again, I got this shape, which is the same as what I have over here. You won't have time to make a table, I guess is the point I'm trying to make, even though we've spent a couple of problems doing that.
Uh-huh.
You're going to want to do it through transformations.
So which negative sign makes it flip, not across the x-axis, but just flip from
Yeah, so let's go through this one more time here so you can see it. 2 to the x looks like this. That's 2 to the x. 2 to the -x looks like that.
Okay.
Then -2 to the -x is the last one.
Okay.
So let's try to do 11 where we're not making the table. And the fact that it's E makes it tough to even make a table because it's, you know, you don't have a calculator. So first thing is like, this is not written kind of in the correct way. It would be -1/2 e to the -x plus 1.
Mm-hmm.
Okay, so let's go through what each of the transformations do for this one. So your parent function is e to the x. So your e to the x looks like this. E to the -x does this. This is e to the, so this is e to the x, this is e to the -x. So we've taken care of that. The negative flips it. So this is -1/2 e to the -x. The -1/2 also does something as well to it, but that's not very important. But then the +1 shifts the whole thing up 1. So I've almost got too many here, but it moves everything up one point.
All right.
If that doesn't look familiar,
Yes, it does.
okay, oh, that's good. All right, so that takes care of those. I mean, do you want any more examples like this, or do you want us to move on to something new?
No, those are pretty
Okay.
easy.
So next thing,
The next ones were 17, 23, and 24.
okay, yeah, I see 17, 23 on this page. So yeah, let's do this.
I accidentally cut off 24.
All right, so there's 17. And it says y equals c a to the x. Okay, and this is like the worst type because you're not given, you really want that point on the y axis. That's the best ones. We don't have it. So let's substitute these values into the equation. I'm actually going to do this top one. I'm going to do this one first. So 24 equals ca to the power of 3. Just putting those numbers in for x and y. And there's 2 variables, and that's bad. Now I'm going to put this other one in. 6 equals ca to the power of 1. This one also has 2 variables. Okay, now there's sort of a cheat here, a shortcut. You can actually divide these equations. Now you might in class have like solve for like a or c and substitute back in, but you can actually just divide these equations. So 24 divided by 6 is 4. C divided by c is 1. And then a cubed over a to the 1 is a squared, because when the bases are the same and you're dividing, you subtract the exponents. Now this produces a potential problem, because when you solve for a is plus or minus the square root of 4, or plus or minus 2. Now, based on this, the fact that it's a growth,
It'd be 2.
it would be 2, it would be positive 2. But if you didn't have the graph, and I'm sure your instructor probably just give you the points, you might not see that right away. Okay, so you go back to the original. and you write y equals c times 2 to the x, and you just use one of the ordered pairs to find the value of c. So I'm going to use this first one, 6 equals c times 2 to the power 1.
And you solve for C.
Right, and c equals 3. Put that back in. Y equals 3 times 2 to the power of x. You cannot combine these. If you need to, you can put 2 in parentheses, but you have to do the power first, then multiply by 3.
Okay. That's not too bad.
Yeah. So 18 would be one you might try to do on your own.
See, let me pull it up.
Yeah, you don't do it now, but that's the kind of thing you would want to definitely be able to.
I like the you dividing both of the things. That made
Yeah,
it really simple.
It's a bit of a cheat. It does work. It's correct. And there's no exceptions. But if you do them in, like if you did 6 on top and 24 on the bottom, then it's a fraction, so it's not as clean. But that's
Oh,
why.
you want to do it with the bigger
Yes.
Y value
Yes,
on
exactly.
top? Okay.
Exactly. Okay, can I move to 23?
Yeah, can you see it? It's cut off on my.
Yeah, it's just the limit as x goes to infinity 1.001x. Is that right?
Yes.
Okay, so there's a property. The limit as x goes to infinity 1 over n. I'm sorry, 1 over x to the p. Well, maybe you're not quite doing this. Let me just put that over here. If this were the limit as x goes to infinity 1 to the x, do you know how to answer that? Do you know what 1 to any number is?
No. Or
It's
no,
always
not
1.
off the top of my head.
It's always 1.
Okay.
So if it's 1 to
That
the
makes
first
sense.
power, 1 to 1,000, it's always 1. The fact that it's not 1 is what presents this problem. That's where I was going with this. So this right here, and this is probably what your instructor wants to see. This is the limit as x goes to infinity 1 plus 1 over 1,000 to the power of x. Okay. Now, this is kind of not correct what we're about to do, but this thing right here is what grows indefinitely. This continues to grow forever. So because this number inside here is just bigger than 1, this thing grows forever. Because we know like 1 to the x, this is 1 to the x plus 1 over 1,000 to the x. This goes to 1, but this just goes forever. It's always getting a little bit bigger each time. So there's not like any work here. It's like a definition. So let's say I asked you the limit as x goes to infinity 1.000000001 to the x. This also goes to infinity.
Okay.
They all go to infinity if it's not 1. But there's other examples here, and that's why I guess I gotta be careful here, either giving you more examples or more explanation.
So the limit would just be infinity.
Yes.
Okay.
But it's because this 0.001, it grows. Like even though it looks really small, it continues to compound. And infinity is infinity. It's so far out we can't understand it. So it just continues to grow forever. This over here, this is what I was going with. There's a few of these rules like limit as x goes to infinity, e to the minus x, that always goes to, like, there's a bunch of these kinds of rules that help, but they're kind of related to what we did, but not completely. I may have made it more confusing than not.
So if it was just a 1 in there, then the limit would be to 1. It should be 1.
Yes, yes.
All right, that makes sense.
About 31 through 34 here. What do we got to look at?
Wait, we're number 24.
Oh, we need to do 24?
Yeah, 24.
Okay, sorry, I didn't catch that. This one is slightly easier to explain and more, I think, understandable.
Uh-huh.
So let's look at this together. All right, limit as x goes to infinity, e to the minus x squared. This can also be written as limit x goes to infinity, 1 over e to the x squared. And that's just using the property of x to the minus n equals 1 over x to the n, using that property there.
Uh-huh.
So why is this helpful? Well, what is 1 over infinity? I'm basically saying, what is 1 over a large number? And it's 0. And if that's not, if that's, you don't believe that, like 1 over 10 is 0.1, sorry. 1 over 100 becomes 0.01, 1 over 1,000 is 0.001, and so on, right?
Uh-huh.
So the bigger this number gets, this thing actually does go to 0. So what happens down here? When x goes to infinity, what happens to e to the x squared? Well, what does the graph of e look like again?
Yeah, it looks like that.
So this x squared actually just makes it grow even faster. So what happens at infinity? This thing is, so this e to the x squared goes to infinity. So this is approximately 1 over infinity, which is why it goes to 0.
Okay.
I'm not sure I convinced you of that, but let me know if you want me to do more
I
explanation.
don't know. It just doesn't make sense to me how
I know,
it goes
I know,
to
I know.
0.
Yeah. So let me ask you, let's look at the graph of e to the x. As x goes to infinity, what happens to f of x? So the graph of e to the x looks like this. So what happens as x goes to infinity? As you go this way, what happens to the y value? How high up
Goes
does
to
it go?
infinity.
Goes to infinity. So if I give you f of x equals e to the x squared, it's going to be the same thing. As x goes to infinity, f of x also goes to infinity. So let's go back and look at your problem again. And I wrote it out as limit x goes to infinity, 1 over e to the minus x squared. I'm sorry, positive x squared. This actually is broken into the following. It's the limit as x goes to infinity of 1 over limit as x goes to infinity e to the x squared. So as x goes to infinity, what's the limit of this thing? What does this become? Keep in mind, this is just a horizontal line. This is a function here.
It'd be 1.
It's always 1. This one you just answered for me. It's infinity.
Okay. That makes more sense.
So 1 over infinity is 0. Okay.
That makes more sense.
I wish we could do a lot more examples of these. Maybe we will, but it'll make more sense the more that we do.
Uh-huh.
Okay, what's next here
Um,
to look at?
did I not send you all of them? Hang on. Sorry.
Yeah, I'm seeing 31 through 34, then 35 through 38.
Oh, okay. Yeah, I skipped. Okay. There are 3 other problems, but I know how to do those.
You're welcome to send them over. Text,
Yeah, let's do
email, whatever.
31, 33, 35. Those are the 3 ones that I have listed on there.
All right, so 31. Yeah, okay, there's a lot to do here. Show that f is 1 to 1. All right, so part A, do we have to do all parts for this?
Um,
It's fine if we do. I just want to make sure. All right. So it says, show that it is 1-to-1. If you graph this thing, which I think is the only way to show you this, looks like this, and it passes the horizontal line test.
Yep.
Okay. Now, part B is the weird one. I always get this confused, but you have to be given a value like this, and you set 8 equal to x cubed, and you solve and x equals 2. So you have to do that first. You have to like set the thing equal to 8, like, or whatever they give you for a. Like that's step 1.
Right.
Then you have to write down the derivative thing, which I believe is f inverse derivative at a equals 1 over f prime of a. Is that right?
Yes.
Okay. This is never used again, by the way, in calculus. So this is like the only time you ever do this. It's really weird, but they have you do it here.
You introduced that to us today, that formula right there.
Yeah, so you take the derivative of the original. So y prime is 3x squared. And because 2 is the place where you care about it, it's essentially it's 1 over 3x squared, and then you put that 2 in for x. So it becomes 1 over 3 times 2 squared, 1 over 12. What questions do you have, or what's unclear about
No,
that?
that makes sense.
Okay.
I was looking at the next, like C
Yeah.
and D.
Yeah, so we kind of did C part 1 because it says find f. Oh, it says calculate f inverse of x.
Mm-hmm.
All right, and f inverse of x is okay. So we actually can do it. So this is you actually learned this from probably a previous class you took. You switch x and y, and then you solve for y. So y equals the cube root of x. Is that okay?
I thought it was you solve for X.
No, once you switch x and y, you switch x and y, and then you solve for y.
Okay.
So see how we wrote y equals x cubed, and
Mhm.
then you switch x and y, then you solve for y.
Okay.
We're gonna do another one, so it should be
All right.
reasonable. Okay, so domain and range, and this is important here. So we have f inverse, domain, and range. You see I'm making a table, and you'll see why I'm going to make a table in a moment. So the original function is, I graphed it up here. It has like no weirdnesses. Do you see that? Like it's good everywhere.
Yeah.
So its domain is minus infinity to infinity. Its range is also minus infinity to infinity. The domain of f is the range of f inverse. So basically these have to match.
Yeah, you just flip them.
Yeah. So this will be more clear in the next one because there'll be some restrictions. And then these also have to match. So once you do one, you can get the other is the point, I guess.
All right.
So that's part C. Part D says use your inverse formula. So this is your inverse here. So your f inverse of x is x to the 1/3. And it says take a derivative of that now. And you're like, oh, I know how to do that. It's 1/3 x to the minus 2/3.
Mm-hmm.
Okay. And then evaluate it a day. So a equals 8. So you put that number in here and you should get 1/12 like we got before. It's like a check. It's like do it the correct way and then do it by finding the inverse. And the reason they're doing it here is like to prove it with you, but on an exam you get a function that you can't take the inverse of. So you have to do it the calculus way.
Okay.
So this is 1/3, 8 to the minus 2/3. Okay, and that is the cube root of 1/8 squared, which is the cube root of 1/64, which is 1/4. You would know that 1/3 times 1/4 and 1/12.
Yeah.
It matches. And you're like, yeah, that's great. Then E says to sketch them on the same axis. You actually just want to go back to the original graph here. Okay, and then you draw this line y equals x. So that's x cubed. And then the other one just mirror, like it's a reflection over that. So it looks something like that. It'll be, I think the next example will be more clear, but there's so much here. It's like, oh, like it's like a 2-page question. Ready to move on to 33?
Yeah.
Okay. All right, let me snip it in. Okay, so this one, it's really important that you see that they're telling you the domain right here. Because the graph of 9 minus x squared, here's what it looks like. Boom, boom, and it does not pass the horizontal line test. Okay, so by restricting it here, the graph ends up looking like the following. It starts up at 9 and it goes down like that. So does that pass the horizontal line test? Yes. That's why they have to restrict the domain.
Okay. I see.
Okay, so as I mentioned before in part A, that's part A. That's part A. I guess graphing it's the best way to do it. Part B, okay, is you have to set this, whatever the A value they give you, 8 equal to 9 minus x squared. There's confusion. Sometimes students put it in here and then it never works. And it's all backwards. So you just try to remember what to do. You solve and x equals plus or minus 1. So which one is it? Well, where is our domain? Must be positive 1 because this is only good from 0 to 3. Do you see that? Does that mean like, okay. So then we need to find f inverse prime of A, which is 1/f prime of A. Okay, and so we need to take the derivative of the original. What is the derivative of 9 minus x squared?
2x or negative 2x.
Negative 2x. So this becomes 1/negative 2x, but then our A is 8. So this becomes losing my mind here. It's this x value. So why am I losing my mind here?
So it'd be negative 2 times A basically.
Yes, you put that x value in. No, not 8, not this x value, the 1.
Oh, okay.
Sorry, that's why I get confused because there's so many moving parts here. Times 1, so it was negative 1/2.
Could you re-explain how that is 1?
Yeah, because we're using that value there.
Over here. I had it.
I know it says A, and maybe I'm mixing notations here slightly, but this is the x value you end up using.
Okay.
There.
All right, I got it. No, okay, we're good.
Okay. Calculate f inverse of x. So this is the one that if you start out with 9 minus x squared. Y equals 9 minus x squared. You switch x and y. So it becomes x equals 9 minus y squared. And then you solve for y. So y ends up equaling plus or minus the square root of 9 minus x. And you have to figure out which one it is. So when you look back at the graph, are y's positive or negative?
It looks like it's going down.
But they're positive. Like this goes from 0 to 9.
Okay.
So that helps to tell you, oh, it's the positive one. Now you might not remember to do the plus or minus on an exam, but you probably want to think you want to. I mean, this is like the full on way to do it. Okay, so that's your inverse, and then state the domain and range. So I always make these tables because I feel like they're more helpful when you're trying to like organize your information. So they tell you the domain of the original is from 0 to 3. And that's up here in the problem, 0 to 3. The range they don't tell you, you can get from the graph. It's basically by evaluating the two endpoints. Okay, so if I like this point up here is 0, 9, this is 3, 0, our domain goes from 0 to 9. Or I'm sorry, our range goes from 0 to 9. The y values. The range is the y values.
Yeah.
So that goes from 0 to 9. And if you can figure that out, that's where it's like, oh, now I know my inverse domain, and now I know my inverse range.
All right.
All right. So now part D is to take the derivative of your inverse function right here. So this is where you need chain rule and stuff. You need y prime. So remember, this is 9 minus x to the 1/2 power.
Yep.
So it becomes 1/2 9 minus x to the minus 1/2 power. What is the derivative of 9 minus x?
-1.
Good. Okay. So then we evaluated at our a value. Our a value was 8. That's where it's confusing because here you're using 8, and the other one we used 1. So this is 1/2. And then negative 1/2 means 1 over the square root 9 minus 8. So this is 1/2, 1 over the square root of 1 times -1. And that does in fact reduce to -1/2.
Good with me.
It would be understandable if this was not so clear. And I'll try my best to do a better job of explaining it.
You're doing good.
1, 2, 3, 4, 5, 6, 7, 8, 9. So the first one says draw, and I'm doing this correctly now. That's F, 0, 9, 3, 0. That's F. And then it's reflected over the line y equals x. And the reason I'm doing it this way is because it's easier to do it like this rather than to try to remember like what does a square root look like, or cube root, or whatever it ends up being. It's literally a mirror. So so like every point is reflected, and we've got our inverse function here, square root 9 minus x. So I don't want to do this. So I actually have to go out further here. 1, 2, 3, 6, 7, 8, 9. Okay, so this looks like that. That's the other one. I went too far, but it's close enough.
Did you go back up?
Sure. This is F inverse.
To part, I think it was D.
Yeah.
Yeah, okay. So I just want to walk through the solving process.
Okay. So you find your derivative.
Yep.
And you did that. You got that. The value you put in is 8,
Uh-huh.
not 1, because use that in the other, like the other way of doing it. So
Mhm.
you're putting just in 8 for that. Now this negative 1/2 power is really, 9 minus x to the minus 1/2 is the same as 9 minus x 1 over to the 1/2.
Mhm.
And anything to the 1/2 power really means square root.
Okay.
And then you're just putting that number in and simplifying.
Okay. All right.
I'm only going fast because you know how to do this and you can look at it later. It's
Very good.
one of those steps.
Look through all those. I got some more.
35. Do you need to do 35?
Oh yeah. Never mind. There's one more.
Okay. So this is one of those where you cannot find the inverse directly. This is your exam question. So this is where it's a little bit dicey. You have to set 4 equal to this thing over here, 2x cubed plus 3x squared plus 7x plus 4. And then you have to guess values.
Uh-huh.
Okay. This is where you're gonna not like it. So here are the ones you're gonna try in general, like 0, maybe 1, maybe -1, but like in that order. And here 0 works. X equals 0 works.
Yeah.
Okay, so now you got the value. So now your f prime, your f inverse of x prime, whatever, you need to find the derivative of this thing.
Mhm.
And you can do that. That's why you learn all that stuff. So 6x squared plus 9x plus 7. And then the number that goes in there is this one you just found.
That'd just be 1 over 7.
Yes. Does your instructor ever make comments like, this becomes a really fast problem if you know how to do it, kind of thing? And this is an example of that. It's really not that much work if you
Yeah, he went over an example like this where you just plug in 0 and
Yeah.
it works. Like
Okay.
you have to guess which value would work.
Okay. All right, well, we got 10 minutes here. So where would you like to go next? What else would you like to work on today?
I got some more problems. I didn't think we'd get through them that fast, but everything's like making sense to me. So just try to. I was gonna schedule another one tomorrow, and was gonna go over these ones, these next ones.
I've only got one time tomorrow because I'm traveling. Unless you need something earlier in the day, can do
What
that.
time is that?
You're in. What time zone are you in?
Central.
Central. It'd be at 6.
That's fine with me.
Okay.
All right. I just lost track where it was. Oh, golly. Oh yeah, there's a lot more problems for this section. All right. Let's do. All right, this is a differentiation of logs,
Okay.
and it would take too long for me to.
Can you snap a quick picture and text it to me? That might be the
Yeah,
fastest.
yeah.
And then that'll get us at least something to work on here for the rest of the time.
Is it 520-501?
Yes.
Okay. All right, it says here. Or has it said yet? All right, it is.
Great. So which ones would you like to work on?
The odd number ones.
Okay.
Obviously, we won't get it through all of them, but
Yeah. So number 1 says f of x equals log base 10 x cubed plus 1. So what I'm gonna do is provide the derivative rule to the right to help here. So log base b of x, the derivative of that is 1 over x times the natural log of b. And then if there's a chain rule, it's over here.
Uh-huh.
Okay, so this one does have a chain rule, but in short, this is critical. It's 1 over whatever's inside here times the natural log of the base. What is the base?
10.
10. And then times the chain rule of this. What's the derivative of this?
3x squared.
And you're done. Now you can simplify if you want, but that is it for that.
I guess the one with the easy, you just have to memorize the formulas
Yeah.
because we wrote them all down. There's 4
Yep.
of them.
Number 3, f of x equals sine natural log of x. So you have to be able to take the derivative of the outermost function. What is the outermost function here?
Sine x,
Yeah, so what's the derivative of sine?
cosine.
Cosine. Keep the inside function. Now d dx of ln x is always 1 over x, or whatever's inside, whatever you're taking the natural log of, and then you multiply by the chain rule. So here the derivative of ln x is 1 over x.
And that's it.
That's it.
All right.
5 f of x equals natural log 1 over x. I'm going to show you 2 ways to do this. The first way is exactly the way we've been doing it. What is the derivative of ln? d dx of natural log of x. It's 1 over whatever's inside there. So it's 1 over x.
Okay. Oh, okay. It's 1 over
Whatever's
inside.
whatever's inside
Okay.
there times the derivative of the inside part. Okay, so 1 over x is really x to the minus 1. So you can do your power rule stuff. It ends up being minus 1 over x squared.
Mhm.
This reduces to minus 1 over x. You can think of that as being over 1. This x cancels with this x.
Okay.
Okay, now way 2. This is way 1, and then here's way 2, because you might actually see this. There's a property, natural log a over b equals natural log a minus natural log of b.
Oh, yeah. Okay.
So this right here becomes natural log of 1 minus natural log of x.
And that's just the answer.
No. That's just separating it. Now the natural log of 1 is 0, but let's just say it was a 2 up top. It actually doesn't change it. The derivative of a constant is always 0, right?
Uh-huh.
The derivative of natural log of x is 1 over x. And the negative just comes with it. And see how these are the same?
Oh, yeah. Okay.
So
Like
that's just something to think about. Like
the second way is easier.
yeah, like in question 9. Can we do 9 next? Will that be okay?
Yeah, go for it.
All right. So 9 really emphasizes this. And that's what your instructor wants you to do, by the way. This isn't like a cheat that they don't want you to do. So this becomes natural log a minus x minus natural log a plus x using the properties. Okay. So the derivative, and this is g of x. The derivative g prime of x, it's 1 over the inside part times the derivative of the inside parts. What's the derivative of a minus x? And keep in mind, a is a constant.
Would it be -1?
Times -1, yeah. Minus 1 over a plus x times 1. And then you could, you have to work with your instructor to decide if they want you to reduce this or not.
Yeah, he'd probably just do -1 over a minus x minus 1 over a plus x.
All right, so let's make 7 our last one here.
All right.
And because this one, it's got quite a bit to it. So this one this is a product rule first. And the dividing point is right there.
Mhm.
So this is that UV.
Yep.
So it's UV prime plus VU prime. All right, so your derivative is, okay, so we'll keep the first, right? Sine X. What is the derivative of natural log? It's always 1 over whatever is inside there, whatever is inside that. So 1 over 5x times, what's the derivative of 5x?
5.
Just 5. Plus, what's the derivative of the first? Derivative of sine is
Sine.
cosine. Okay. Keep the second natural log of 5x.
All right.
Great.
You go back up to number 9 real quick.
Absolutely. Yeah.
I just want to ask, so how I would probably write that on the, if it was on the quiz, would be negative 1 over a minus x minus 1 over a plus x as my answer.
Yeah, it's fine.
That work?
Yep.
Okay. All right, cool.
Great. Well, that takes us to the end of our lesson today. Thanks so much for scheduling. I'll send you the notes and screen recording out later today or in the morning. And if you want to schedule for tomorrow, I'll be happy to help.
All righty.
Thanks. Have a great night. Bye now.
Yeah.